All right, here we go. Wrapping up chapter 11 here with 11.3 and 11.4. Okay, so this video will cover only 11.3, which is the third conic, the hyperbolas. Okay, so let's start with a geometric definition of what a hyperbola is, similar to the way we did for the parabola and the ellipse. Okay. All right, so the hyperbola is the set of all points xy such that its difference. So last time with the ellipse, we did the sum of these distances, right? Here we're going to be looking at the difference. Okay, so such that its difference of its distances from two fixed points F1 and F2, also called the foci, is constant. So I will draw you a picture to help you understand what we're looking at. Okay, so here, so what happens is we have two fixed points. So maybe we have that one and this one. And so last time we looked at an ellipse, which is like an oval, right? So here what happens is it's like you have two parabolas, okay? And so you have a center point, okay? And what happens is you have one parabola that maybe looks like this, okay? And then the other one that looks like this, okay? And the distance that they're talking about is, okay, so if you, let me take that off. If you take a point on the hyperbola, okay, so let's take this one, okay? And you look at this distance and this one over here, okay? So what happens is if I have this distance, I'll call it D1, and I'll call this D2, then D1 minus a D2, okay, I'll do absolute value. So it doesn't matter which one we do first. Okay, so D1 minus D2 is equal to some constant, right? And if I take another point, let's do purple. If I take another point, like let's say this one right over here, okay? And if I look at the distance to the two different focus points, I'll call this C1 and I'll call this C2. If I look at the difference of those distances, so C1 minus C2, what happens is I get some number and it turns out it's going to be the same number, C. Okay, so if it's 7, then it's going to be 7 here as well. Okay, so all of those points that have, let's pretend it's 7, have a difference in those distances that's 7. They're all going to land on these two parabolas. Okay, this hyperbola. Okay. All right. So let's go ahead and take a look at the equation. Okay. Okay, and in this case, I will definitely write the 2 that they have in the book because there isn't a way to get all the information for both using only one. Okay, so let's take a look here. If you have this one, looks very similar. Looks very similar to the ellipse, except here it is subtraction. Okay, so what do we know? We know that the center is at 0, 0. We know that the horizontal axis length, so a lot of the information is going to be the same. The horizontal axis length is whatever A is times 2. Okay, and vertical axis length is whatever B is times 2. Okay, and we also know that the 2 focus points, the foci, are also C units from the center along the, we don't call it major axis here, we call it the transverse axis, but it's like the main axis, okay? And I'll tell you how you can tell if the main axis is the horizontal one or the vertical one. Okay, so I'll tell you that in a minute. Here, you know what? Let me give you the formula for C first, and I'll tell you how to tell. Okay, where C squared equals to A squared plus B squared. So that's different. The one for the ellipse is subtraction. So here the C squared formula is the Pythagorean theorem. Okay. All right. So, and here, when it's written like this, okay, so the reason why we need to have 2 of these is because subtraction is not commutative. Okay, so when we have the x squared over a squared minus the y squared over b squared, that's completely different from having y squared over b squared minus x squared over a squared. Okay, so when it's written like this, then the transverse axis is horizontal. Okay, so then that means that it's going to open up like this, and your focus points are going to be here and here. Okay. All right. Let's take a look at the other equation. So where the y squared is first. Okay. So here it's x squared over a squared first. So now let's flip them around and okay. So when it's like this, we still have a lot of the same things. Okay, so we know that the center is at 0, 0. We know that the horizontal axis length is going to be whatever A is times 2. So that's still the same. Vertical axis length is still the same. It's whatever B is times 2. Okay. And then what did we have here? We have the 2 focus points, still the same thing. So the only thing that's going to be different is this last line. The transverse axis is not horizontal, it's vertical. Okay. So C units from the center, again, along the transverse axis. And where C squared equals A squared plus B squared. Okay, so everything is still the same. So the only thing that's different is this right here. Transverse axis is vertical. Okay, so then your hyperbolas look like that, and you have a focus point in there and another one in here. Really should be more centered, but writing on this doesn't come with precision. Okay. All right. Another thing that we're going to be looking at for both of these are the asymptotes, and I'll talk about that in a minute. Hopefully you remember how to write the equation of a line. Okay, so I don't want to put it here just yet in case we need more explanation on that. Okay, all right, so let's take a look at this example. So let's go ahead and graph, find the foci, asymptotes, and vertices. Okay. All right. So they're not asking me to find the equation of the hyperbola. Okay. So normally I start with graphing. Okay. But here they don't ask me to find the equation. So let's go ahead and here's the equation actually. X squared over 9 minus y squared over 4. Okay, so let's just extract all the information that we just wrote above from this equation. Okay, so we know that the center is at 0, 0. We know that the horizontal axis length is square root of 9, so that's 3 times 2. Okay, so that's 6. Okay, 3 on each side, okay, from the center. Okay, and then the vertical axis length is square root of 4, which is 2. So 2 times 2, which is going to be 4. 2 on 2 above and 2 below. Okay. The foci, so we're going to find C squared. So C squared is equal to 9 plus 4. So C equals the square root of 13. Okay. And we also know that the transverse axis is going to be horizontal. Okay. So we know it's going to be this kind. Okay. All right, so let's go ahead and graph this. All right, center is at 0, 0, horizontal 6, 3 on each side. 1, 2, 3. 1, 2, 3. Vertical 2 up, 2 down. Okay. Okay, so here, the longer one doesn't necessarily mean that's the major axis. You could have the transverse axis, major axis. You can have that one be the short one. Again, what determines it is the position, whoever's in position right here. Okay, so that tells me the x-axis is the transverse axis. Okay, all right, so the way you go about doing this graph, okay, so normally this would be your ellipse, but we're not going to draw an ellipse. Okay, so what you do here is you're going to draw a rectangle where these points that you plotted are the midpoints. Oops, went too far. Midpoints of each line, each side. Okay, so you're going to draw your rectangle, and then you're going to draw an X. So think like X box. Okay. All right. And what happens is these points right here, here, let me show you. These points right over here, this one and this one, okay, because we already know it's going to be these sideways parabolas, right? Okay, so these points that are on the rectangle are going to serve as the vertex, okay, of for each one. Okay, if it were the vertical kind, then these points on the side of the rectangles, this one here and this one here, would serve as the vertex of the parabolas. Okay. All right. So, but we know it's going to be the sideways one. Okay. So then I just go ahead and from that vertex, I go ahead and draw my parabola. And those diagonal lines help to guide the size of your parabola, like how wide it starts to get. Okay, so make sure you don't do this. So I'll see students do this. Okay, so number one, you didn't hit the vertex. And number two, you aren't using those diagonals to help guide the shape of that parabola. Okay, so make sure you use that vertex point and you really go towards those asymptotes. Okay. All right, very good. Oh, our focus points, square root 13. So that's somewhere between 3 and 4. So from the center, 1, 2, 3, point something, 1, 2, 3, point something. Okay, so that left one's a little sloppy there. Okay, so let's see. Let's just label some things. So I see that my vertices, we can just count them. We have one of them at 3, 0, and another one at negative 3, 0. And then my foci, we have it at square root 13, 0, negative square root 13, 0. Okay. And the equation of those diagonals. Okay. Those are our asymptotes. All right. So the asymptotes. Okay, so hopefully you remember y equals mx plus b, right? Here, this is just an aside thing, a quick review. Y equals mx plus b, right? That's the equation of a line. And this is our slope, right? That's our slope. And this here is our y-intercept. So if we know those two things, we can write the equation of a line. So let's do this positive line first, and then we'll do this negative line second. Okay, so this positive line, we see that the y-intercept is 0, so b is 0. Okay, and then I see that the slope is the rise and the run between 2 points. So I'm going to use this point and this point. Okay, so when I do my rise and run, I rise 2 and I run 3. Okay, so that's my slope. Rise 2, run 3. So my first equation for the asymptote is y equals slope, which is rise 2, run 3, x plus b. And b is my y-intercept, and I can see it, that it's 0. Okay? The y-intercept is where the graph crosses the y-axis. Okay? So it's at 0. So this would be the equation of that positive line. Do you have to write the 0? Nope. Okay, so let's just leave it like that. Okay, and then let's do the negative line. Okay, so let's look at the negative line. We see that the y-intercept is also 0, so b is going to be 0. Okay, and let me get a different color. I'll do green. Okay, so I'm going to use this point on the line. So rise, -2, run 3. So that's my slope. -2 over 3. Rise over run. Okay, so the other one is going to be y equals -2 over 3x plus 0. Okay, because the y-intercept is 0. Again, do I need to write the plus 0? No. Okay, so you can just leave it like that. Okay, so for the asymptotes here, it's basically going to be whatever your rise is, your run is, because all of them are centered at 0, 0 in this section. In the next section, we start shifting these around, and then maybe you know the y-intercept because it's very clear, and maybe you don't. And so if you don't, then you'll need to do the equation of these lines algebraically. Okay, I'll have an extra video on Canvas if you forgot how to write the equation of a line. Okay, let's see. Okay, let's go ahead and try another one. Okay, so let's find the asymptotes, foci, the graph, and the vertices. Okay, and suppose that we have this. Here's the equation, y squared over 9 minus x squared over 16 equals 1. Okay, all right, so let's write down all the information that we can get from that equation. We know that the center is at 0, 0. We know that the horizontal length is square root of 16, which is 4. So 2 times 4, which is 8. We know that the vertical distance, and remember the horizontal one is under the x. X is horizontal. Okay. Vertical, that's y. Okay, so underneath the y squared is 9. So square root of 9 is 3. So 2 times 3. Okay. And then my foci, we know c squared is equal to 9 plus 16. So that's 25. So c equals to 5. Okay. And then we know that since y squared over 9 is first. It's positive. Okay, so the y-squared term is positive. So we know that the transverse axis, so like the main axis, is going to be vertical. Okay, so I'll be drawing it like this here. Okay. Okay, so center at 0, 0, horizontal 8. Okay, so 4 each direction. 1, 2, 3, 4. 1, 2, 3, 4. Vertical is 6, so 3 up, 3 down. 1, 2, 3. 1, 2, 3. Okay. So now I can do my X box. Okay. So we can see here that even though the vertical axis is shorter, it doesn't matter that it's shorter. My hyperbola will still be vertical, even though this is the shorter distance compared to the horizontal axis, right? Okay. So again, it just goes to show you that these lengths don't determine which one is going to be the main one. What determines it is who's positive. Okay, this negative goes with them. This one's positive, so it'll be vertical. Okay. Okay, so we've got one asymptote. Okay, and then we know that it's vertical, so I'm going to start right there on that midpoint on the side of the rectangle. That's the vertex. And I will go towards the asymptotes. Okay. All right, so let's get all the information. So we need to get the asymptotes, the foci, and the vertices. All right, so we can see the vertices. Okay, so we can see those. Okay, that's this point right over here, which is 1, 2, 3, 3, 0, 0, 3. And the other one down here, so that's 0, -3. Okay, the foci is 5, so 1, 2, 3. So remember, the focus points are inside, okay, inside these parabolas. So 1, 2, 3, 4, 5. One, two, three, 4, 5. Okay, so we can see we have one at 0, 5 and another one at 0, -5. Okay, and now our asymptotes, those are our y equals mx plus b. Okay, so let's do the positive line first. So this line right here, okay, the positive line. Okay, so I'll use this point, and I rise 1, 2, 3, run 4. So 3 over 4. Okay, so y equals 3 over 4. X plus b, but b is 0. Okay, and then let me do the negative line. Okay, so the negative line, I will use this point over here and this point here. And you can see, kind of obvious, we're going to get -3 over 4. Okay, so the other one is y equals -3 over 4x. Okay. And I believe that's everything. Vertices, graph, foci, asymptotes. Yeah. Okay. All right, so let's take a look at writing equations. So just like with the others, you want to graph all the information first. That way you can count all the stuff that you need. Okay, you can see what you actually have. Okay, so let's take a look at this one. Find the equation of the hyperbola centered at 0, 0 with foci at plus minus 5, 0, and vertices at plus minus 3, 0. Okay, so writing equations, graph everything first so you can see what you have. Because you can tell a lot from graphing the information. Okay, so we know it's centered at 0, 0, a focus point at 5, 0, and -5, 0. So 1, 2, 3, 4, 5. That's a focus point. Put a letter F there so that you don't think it's a vertex. Okay. 1, 2, 3, 4, 5. So there's another one. Okay. Vertices at 3, 0. 1, 2, 3. Okay. I'm going to put a V there so I can kind of keep track of everything. And -3, 0. 1, 2, 3. Okay, so just by looking at that, I can already see which way my branches are opening, right? Since that's a vertex and that's a focus, then I know it's doing this, right? And since this is a vertex over here, okay, so since this is a vertex right over here and that's a focus, then I know it's opening to the left. Okay, so I know it's doing that, right? Okay, and knowing that, I already know which of the two equations I'm going to use, right? Because we have two of them. One where the x squared is first and positive, and the other one where the y squared is first and positive, right? So because it's opening horizontally, then that tells me that I'm going to be using this one, right? Okay. So I know I'm going to be using this one. Okay, and so that means I need to know these two numbers right over here. Again, oftentimes you'll be given one and not both. If you're given only one of these, you're probably also given the focus points, and we are. Okay. All right, so let's see what we have here. This distance from the center, right? So this distance here is 3, okay? So 3 squared, okay, so here, let me write this. 3 squared is 9, Okay, so we have x squared, and we know that distance is 3. Okay, and then this one, we don't know. Okay, so we don't know b squared. Okay, but we do know what c is. Okay, we see that c, let me use a different color. C is the distance from the center to the focus. And we see that that is 5, right? Okay, and we only need to know one of those lengths and the focus point, and we can find the rest. Okay, so C is 5, and we also know this formula. Okay, all right, so C squared. So 5 squared equals A squared plus B squared. Okay, so 25 minus 9 is 16. Okay, so there you go. We're done. So it's x squared over 9 minus y squared over 16. Okay, so you can see how graphing everything gives you so much information from, this is hard. A lot of students just memorize formulas, and then they don't do this part, and they just try to make the numbers fit into formulas. To me, you don't have to memorize anything except for maybe this formula right here, and all you have to do is deduce all the information. Okay, so once you plot everything that they give you, you can be like, okay, well then, since the vertex is there and the focus is there, it must open like this. If it opens like this, then it must be this equation, not the other one. Okay, so then go ahead and find out what these numbers are. Okay, we know this one, but we don't know that one. But we know this, and we know this. So now we can find this one. Okay. All right. Try this one. And then check back to see if you get the same answer. Okay. So find the equation of the hyperbola centered at 0, 0 with foci 0 plus minus 10, vertices at 0 plus minus 8. Okay, so again, start with graphing all the information first. Okay, so go ahead and hit that pause button and see if you can get this one right. Okay, center at 0, 0, focus point at 0, 10. That's a focus point. I'll put an F. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Vertex at 0, 8. And 0, negative 8. Okay, so already I know right off the bat, just by looking at this, I can figure out that it's going to be this kind and not the horizontal one, right? Okay. And if it's the vertical kind, then I know that it's going to be this equation where the x squared is positive. Okay. So let's go ahead and we know the y distance. So let's take a look at that. Okay. So here, this is my y distance, which is 8. Okay. So it's going to be 8 squared. Okay, so it's going to be y squared over 8 squared minus x squared over a squared, which we don't know. Okay, but we do know c, which is going to be the case. If you're missing one of those denominators, you're probably going to be given c. So let's go ahead and take a look on our graph. Okay, and this here is my c distance, which is 10. Okay. So now I can use that Pythagorean formula. Okay, so we know c is 10, and we also know the formula. Okay, so then now I can solve for b. No, I'm solving for a. All right. All right, c squared, so that's going to be 100. A squared, we don't know, plus b squared. So that's 64. Okay. So subtract 64 both sides, and I get 36 equals a squared. And so there's your denominator for x squared. Okay, so the answer is going to be y squared over 64 minus x squared over 36 equals 1. Okay, so that is it. Okay, so those are the 3 conic sections that we are covering in Chapter 11. Circles, we covered that back a few sections ago. Okay. All right. So if you have any questions, make sure you email me or you message me through the Remind app. Okay.